Okay, so let's take a look at this here. It says find each product. So for the first one, this is something that we should have been able to do after we did 7.1 notes. So it says find each product. So how am I going to find the product of this polynomial? Ben? How am I going to find the product of this polynomial? 3x squared y times 6x to the fifth y. I'm not going to distribute. No, because they're not like terms. Because if they're like terms, they have to have the same variable with the same exponents. Well, they don't have the same exponents. Ben?
Just times the 3x squared top 2 with the 6x squared top 5 is y with y.
Yeah, so I'm going to multiply those together. So when I multiply my coefficients together, what does that equal? 18. And then when I go to look at my exponents, I have to make sure they have the same base. And when I'm multiplying polynomials with exponents, what do I do with the exponents here? Ben?
You add them.
You add them. So it's going to be x to the
7th.
and then y to the second. And that's going to be your final answer. Do not forget, when there is a variable by itself, it's that invisible 1. It means it has an exponent of 1. So you have y to the first times y to the first, which would be y to the second. Okay. Second question. You're taking a monomial times a polynomial. So you're taking a monomial, one number on the outside, and you're multiplying it times a polynomial. So in order to do that, what's the first step that you're going to do here?
Take 5m squared and n and times it by -2 and then 6 and then
What's that called when you take it times everything within the parentheses?
distribute.
Yeah, distribute. Okay, so what's 5m squared n times -2mn squared? So the way that I do this, I always multiply my coefficients first, and then I worry about my variables and exponents. So when I multiply together my coefficients, what do I end up getting?
-10mn.
Okay, so m, how many m's do I now have?
1.
Well, we have 2 plus 1, which is
3.
3 plus 1 would be
3. And then how many n's do I have?
3.
3. Good. Any questions on how I got my exponents for my variables here? Okay, so now I distribute my 5m squared n to my second term. So what's that going to equal?
30 and 5.
30. Because 5 times 6 is 30. And then m to the what power? And n to the what power?
m to the 5.
Okay,
It's 3.
to the 3, right? To the 5. M to the 5th, n to the 3rd. So m, I have 2 here, and I have 3, so 2 plus 3 is 5. N, I have 1 here, and I have 2 here, so 1 plus 2 is 3. Okay? And then I distribute to my last term. And what is that going to equal?
20m.
20m. 20m what? Squared and n. So I don't have to really worry about combining my exponents and my with the 4 because it doesn't have any. So it just stays the same as what it started with on the 5, what we distributed with. Okay, now I'm almost finished. My next step is to look to see if I can combine like terms. Can I combine like terms here?
Yes.
What are my like terms?
The
No.
Okay, Dylan, I agree with you. Why can't you?
Because none of the things up top are like the same.
None of the exponents are the same.
Oh,
In
okay.
order for them to be like terms, not only do they have to have the same variable, but they also have to have the same exponent. And they don't. See how it's m to the 3rd and m to the 5th? They're not the same.
I'm talking about the n.
It does.
Squared and
It doesn't matter. This is a term that all goes together.
Okay, so when it's like 2 terms, you can't combine. Okay.
So this is a whole term. This is a whole term. And this is a whole term. In order to be like terms, they have to have the exact same variables with exponents. Okay, so therefore, this is my final answer. How many degrees does this first term have?
17.
This is the first term, 6. Second
8.
and third, 2. If I was asking you to write this in standard form, which I'm not going to make you do this if you don't have to combine like terms, which term would go first based on the powers?
30.
Yeah.
And 5.
Yeah. Okay. All right. Let's look at the next one. Ben, question?
The 20m too, we actually have 3 times, and it's basically there's a visible 1 by the end.
Mm-hmm. Correct. Correct. Okay. Now, we're going to take a binomial times a binomial. So 2 terms times 2 terms. So what do I do with my first binomial, Hannah? What do I do with this first binomial? So I'm talking about this guy. What am I going to do with that in order to multiply it? Huh? Not add them together, but distribute. Yeah, I'm going to distribute them. So I'm going to take the first term in my binomial and I'm going to distribute it to every term behind it in the next binomial, okay? So if I distribute 2x times x, that's going to get me 2x what? 2x squared. Then 2x times negative 1 equals, what kind of 2? Yep, negative 2x. Okay? What do I do next, Riley?
Distribute on
Yeah, I distribute my 5. So 5 times x is 5x. And then I distribute the 5 to the negative 1 and get
negative 5.
negative 5. Is this my final answer? Can I box it?
Yeah.
No,
No.
No, why can't I?
combine like terms.
What are my like terms up there?
Negative 2x plus 5x.
Okay? But what do I want to bring down first? Because I want my answer in standard form when I combine like terms.
2.
So 2x squared. Okay, I'm finished with that. I combine my like terms, and what do I get?
3x
Plus 3x. And then bring down my minus 5. There's my final answer. Nice job. Okay, so that's the front side. Let's flip it, look at the back. Now the back, we're going to follow the same steps. We're just dealing with more terms. Yes? Well, I wanted some other people, like these 3, maybe to participate a little bit. Okay.
I've been participating.
You have been participating. Okay, here we go. What is this called? I'm going to multiply a what by a what?
Who's Frank?
Katie. Okay, so this is called a what? What kind of polynomial is this? There's 2 terms, so it's a
5.
binomial times
Try.
trinomial. So we're going to take a binomial times a trinomial. So I'm going to take every number or every term in my binomial, and I'm going to distribute it to every term in the trinomial. Okay? So what's that going to equal here, Emily?
3x
3x what?
squared.
Well, don't forget that invisible 1. So it's actually going to be 3x to the what?
First
1 plus 2 is
4.
1 plus...
I'm so tired.
Let's try one more time.
3.
There we go. 3x to the third power. Then what do I distribute my x to? What do I distribute my x to next?
The 4.
Okay. And what does that equal?
4x
4x what? Don't forget that invisible 1
2.
to the second power. Then what do I distribute it to?
5.
What kind of 5 is that?
Negative.
So that's going to equal
Negative 5. Or minus 5.
minus 5 what? X. Okay?
Would it be the 2 though? Or no?
No, because does the 5 have an x?
No.
Nope, it's just that one lone guy, right? All right, Maddie, next step. No. Not yet. Look up here. What haven't I done?
Oh, it's not last time.
You did do that.
Distribute. Okay.
Distribute my 5. So my 5 distributes to the 3x squared. What does that equal?
20.
She does not have a dog.
Or 15.
I'll stalk her Facebook. She does not have a dog.
Well, your mom didn't respond yet?
Well,
Okay, put it away for now.
She did.
Oh, your mom said no?
No, she said, I don't know.
Okay. All right. What'd you say? So what's that equal, Maddie?
15.
15 what?
X, or X to the power.
Very good. And then?
Yeah, times it, and then 20x the first.
Okay. Yes, you're right. And then,
And then 25.
what kind of 25?
Is it? Would there be an X? Negative 25, but.
Is there an X there at all with the 5s? Nah, so we can't just throw something randomly in there. Now, Maddie, what do we get to do? Combine like terms. Okay, we want it in standard form, so we're going to start with our term with the highest degree. What's the highest degree here? Does it have a like term to combine it with? Bring it on down. Next.
2. 4x to the second power to 15x.
And what does that equal?
2.
Like,
X to the 4th?
no. When you can
Second.
keep them the same. The only time you change your exponents is when you multiply or divide. Okay? Then what?
5x.
How about negative? There you go. Which equals? Negative 5 plus 20.
Oh, 25. That is negative.
15.
15. So if you have $20 and something costs 5, you're going to have 15. So 15x. And then what's my last term I write?
You just break down with negative 25.
Name this guy. What's this polynomial called? You don't have to on your quiz, but you will eventually.
Degree.
I'm gonna write that down.
What'd you say?
6.
6 degree what?
Polynomial.
Polynomial. Good.
How do you know what the polynomial?
Because, so I know it's 6 degree based on 1, 2, 3, 4, 5, 6, right? And then I count my terms. 1, 2, 3, 4. 4 more is a polynomial. And you remember where your chart is, correct? Where you can just look at real fast. Yeah, 4 more.
These questions aren't on the quiz, right? Because
Where you have to name them, not today. On your unit test, I'm going to give you polynomials and you're going to have to name them.
Oh, that's
Okay.
I can use this on
Oh my gosh, you should not fail. You get to use your notes which say, this is what it is.
Am I allowed to?
Then
There's
I
good
will.
examples on this. Am I allowed to use this on the quiz?
Nope, only your notes. That's why you want to make sure your notes are good. Okay, last one. What kind of polynomial is this first one?
Trinomial.
Okay, and what kind is my second one? What is my second one? Okay, so I'm going to take a trinomial and multiply it by a trinomial. So in order to multiply a trinomial times a trinomial, what am I going to do with each of these 3 terms here? I'm going to distribute behind. Good. So I'm going to start with my x squared. So what do I distribute that x squared to, Dylan? What do I distribute my x squared to?
3x squared.
And what do you get?
3x to the 4th
Okay, then I distribute it to what?
to the negative 4th.
And what does that equal?
Negative 4x.
To the what?
3rd.
And last one.
To the 6.
And that equals,
6x to the 7th. Wait.
yeah, 6x to the second. Okay, Josh, next step.
Take the 2x to the 3x to
And what does that equal?
6x 3.
Then?
To the negative 4. You get negative 8x
And next?
to the 6.
And it equals
12x to
12x, just 12x, correct? Okay, I'm going to have to move my answer. I'm out of room.
yeah, so we just draw an arrow.
Okay. Riley, last step. Well, one of the last steps. Do not say that. Quiet. So I distributed my x squared. I distributed my 2x,
I gotta distribute
the negative 1, okay? So I'm going to distribute the negative 1. What does that equal?
3.
How about negative 3x what?
Second.
Okay, then what?
Distribute to the 4.
What?
Negative 4.
Which equals? 2 negatives equal a?
Positive.
So, oh, 1 times 4 is 4, so 4x. And then what?
I have my phone.
Be 6 is negative.
Negative 6, good. I know, I'm lucky I can just kind of move my stuff.
Yeah.
Okay, so after I distribute, my next thing I'm going to do is what? What am I going to do now? Combine like terms, okay? Starting with my highest degree. What's my largest or highest degree here?
3x to the fourth.
Do I have a like term with that?
Bring it down.
Bring it down. Okay, my next one.
Negative 4x to the third.
Okay, and
6x to the third.
so it's negative 4x to the third plus 6x to the third.
2x to the third.
Okay. Next.
6x to the second power, and negative 8x to the second, and negative 3x.
Okay. So you're going to take 6 minus 8 minus 3.
Negative 5.
Negative 5 what?
X.
Squared.
Okay. Next one.
Next one, 6.
12.
12x.
Nope.
12x and
4.
4x, which equals?
I don't have an x after my 12.
16x.
Wait,
I was gonna say 17. And then just write down the negatives.
That would have been wrong. And then negative 6.
And that's our final answer. How many degrees?
10.
10th degree. What's it called?
I don't know.
Polynomial.